You know that chart that was always tacked to the wall in your science class? Well, let's forget that dusty old image. Today, we're going to look at the periodic table for what it really is, this incredible, elegant map for understanding, well, pretty much everything in the universe. So, let's dive in. I mean, just stop and think about that for a second. We've got over 100 unique, fundamental building blocks. Everything from the hydrogen that fuels the stars to the carbon that makes you, you. How in the world do you arrange all of that in a way that actually makes sense? Well, science's answer is this amazing grid right here. The periodic table isn't just some boring list of elements, oh no. It's an incredibly powerful tool that organizes everything by its properties, letting us predict how things will act and react. It's the ultimate cheat sheet for chemistry. So here's our game plan for this tour. First, we'll get the lay of the land, what this map is all about. Then, we'll learn how to actually read it. After that, we'll explore the main regions, the huge kingdom of metals, the totally different world of nonmetals, and finish up with a couple of really special groups. Okay, first things first. What makes this whole thing so powerful? It's all about the organization. The elements aren't just thrown on here randomly. They're put into groups with other elements that act alike, that have similar chemical properties. And that right there, that's the secret to its predictive power. Right. So, you can't use a map if you don't know how to read the legend, right? For the periodic table, that means we need to learn the language of the elements, what their symbols mean, and what those columns and rows are actually telling us. And speaking of symbols, you ever wonder why some of them seem a little odd? I mean, O for oxygen, that makes sense. But why is gold Au? Well, it's because some of these symbols come from their older Latin or German names. So gold is Au from the Latin word aurum, and iron is Fe from ferrum. A little bit of a history lesson built right in. Okay, so the entire layout of the table really boils down to two things, columns and rows. The vertical columns are called groups, and the horizontal rows are called periods. They look simple, but they each tell us something completely different and super important about the elements. Let's start with the vertical columns, the groups. The best way to think about these is like families. Seriously, just like members of a family share similar traits, all the elements in one group have similar chemical personalities. They like to react in similar ways, they form similar kinds of bonds. They're family. Now, the horizontal rows, the periods, tell a different kind of story. As you move across a period from left to right, the properties of the elements change in this really predictable, gradual pattern. You'll go from something like a super reactive metal on the far left all the way over to a very stable, unreactive gas on the far right. All right, we've got the basics down. Time to start exploring. And we're going to start with the biggest neighborhood on this map by a long shot, the metals. They take up most of the left side and the whole center of the table. So what makes a metal? A metal? Well, they've got this classic set of properties you probably already recognize. They're great at conducting heat and electricity, they've got that signature shine, and they're often malleable and ductile. And those last two are really key, as we're about to see. Let's make this real. Ductility is just a fancy word for being able to be stretched into a wire. Now think about copper. It's an amazing conductor, and it's super ductile. Put those two things together, and boom, you've got the perfect material for pretty much all the electrical wires that power our world. And here's another one you use all the time. Malleability means you can hammer or roll something into thin sheets without it breaking. Aluminum is incredibly malleable, and that's exactly why we can make that super thin aluminum foil we use to wrap our leftovers. Okay, time to pack our bags and travel all the way across the map. Over in the upper right-hand corner of the table, we find a totally different crew of elements, the nonmetals. And as you'd probably guess, nonmetals are basically the polar opposite of metals. They're terrible conductors of heat and electricity. If they're solid, they're brittle. Try to bend a piece of charcoal and it's just going to shatter. But what's really cool is their diversity. While metals are almost all solids, nonmetals can be gases, like the oxygen we're breathing right now, or even a liquid. Yep, that diversity is what really sets them apart. They cover all the bases, solids, a whole bunch of gases, and even that one liquid, bromine. For the final leg of our tour, we're visiting two very exclusive, very special places on our map. We're going to check out the elements caught right in the middle, and then meet the royal family of the table that keeps to itself. Okay, see that zigzagging staircase line that divides the metals from the nonmetals?
Right along that line, you find the metalloids, and their location on the map tells you everything you need to know. They've got properties that are a little bit metal and a little bit non-metal. They're the in-betweeners.
And that in-between status gives them a superpower. Metalloids are semiconductors. That means they can be told when to conduct electricity and when not to. And that one property, that's the magic behind every single piece of modern electronics. Your phone, your computer, they all run on metalloids. And at last, we arrive at the far, far right of the table, Group 18. This family has a special name, the noble gases, and they are absolutely the elite, the VIPs of the entire elemental world. So what gets them into the VIP club? It's one simple but profound trait. They are generally unreactive. They have a full outer shell of electrons, which basically means they're perfectly happy and stable all on their own. They just don't feel the need to bond or react with other elements.
And this standoffish personality is actually incredibly useful. Think about neon signs. Because a gas like neon won't react with anything, you can seal it in a glass tube and run electricity through it, and it will just glow, nice and stable, creating those bright, iconic signs.
So, at the end of our tour, what's the big takeaway? The periodic table is so much more than a catalog. Its absolute genius is in its organization. If you know where an element lives on this map, you can make a really good guess about its properties, how it's going to behave, and maybe even what you can do with it. So this one chart organizes all the matter we've ever found. It's incredible. But here's a thought to leave you with. Scientists are always pushing the limits, creating new, super heavy elements in labs that only exist for a fraction of a second. So it makes you wonder, is this map truly finished, or are we still drawing in the edges?